Morning, everybody. I hope you're drying out from being out in the rain. Let's see, we are starting off day 2 of the Purdue Pest Management Conference. For those of you who weren't here yesterday, just as a reminder, we're going to please stay till the end of each session and we'll put up a QR code for you to get your continuing credit hours. You'll use your smartphone to snap a photo of it, and hopefully you're led to a website that takes care of the rest. It is my privilege today to introduce you to the person that is presenting Doing the Math class at 8 a.m. I'm so glad to see all of you. Let's see. Dr. Cassie Krejci is the Head of Science and Innovation North America at Rentokil Initial, where she works with a team of specialized scientists to drive the development of new technology for Rentokil teams around the world. Cassie received her doctorate in entomology from Texas A&M, her Master of Science degree in agriculture from Tarleton State University, and an executive leadership certificate from the Carlson School of Management at the University of Minnesota. She is also a preventive controls qualified individual by the FSPCA and is a board certified entomologist, and her specialties include integrated pest management, product development, and insecticide formulations. And if that's not enough, Cassie serves as the immediate past president of Pi Chi Omega, the International Fraternity for Pest Control Professionals. She recently moved to Dallas, Texas to design and build the North American Science and Innovation Center for Rentokil Terminix, which is a 70,000 square foot research and development facility that is set to open in April 2024. And above all, Cassie loves teaching others the science of pest management, both live and on social media at Cassie the Bug Doc. Please join me in welcoming Cassie.
Is everyone able to hear me? I can hear myself, so that's great. Y'all, it was raining cats and dogs this morning, and I stepped in a poodle. What about y'all? Thank you. That was a joke my dad used to tell me, and it really was crazy weather this morning. But I do appreciate you all showing up at 8 a.m. for a math class on a Tuesday. I feel like the only other spot that would have been worse than this is like the last class of the conference, but I appreciate you being here. So today we're going to talk a little bit about a foundational subject, which is great for all of you who are working on your credits. And you know, that's one of the places that I like to spend a lot of time on social media or in any of the classes is what is the foundation behind what we're doing. Let's go back to the basics and remember all the tools that got us to doing excellent pest control. So doing the math is one of those topics where we can step back and go, oh yeah, I forgot that part. I forgot order of operations when it comes to math. I forgot that trick, you know, that made it a little bit easier. So I hope you're able to leave today with a little bit of, you know, inspiration. Okay, so today what we'll do is we'll spend a little bit of time calculating for chemicals. We'll talk about how that relates to what is on the label, how it relates to making yourself more efficient, but also some tools for calculations that can, again, make you more efficient, make it a little bit more fun, and then Q&A or sharing more than anything. If you have methods, I encourage you to speak up and share them. So I have 2 daughters, and I'm gonna open it up and say that first kid, and for all of you who have children, that first kid is very type A, right? They generally are just like you. That's Callie. She's about to be 8, and she's in 2nd grade, and she likes rules. She likes to follow an order. She likes science, she likes to read. But all of you who are blessed with that second kid can probably attest that they're a little bit different, okay? They have that twinkle in their eye that says, oh, you're not quite right, but you're wonderful, but you are crazy. That's Marin, and Marin is about to be 6 in February, kindergartner, and she's giving me a run for my money. And I bring these kids up because they're both brilliant. Through a lot of hard work, I find them brilliant. But we play this game when we're driving down the road, and it gets me out of iPad time. But I'm like, hey, Callie, what is 2 times 6? And she's like, 12. All right. I go, oh, hey, Marin, kindergarten, what is 6 plus 3? And she's like, 9. And we go back and forth as we're driving down the road. And recently, Marin started getting a lot faster at it. And I was like, this is working. Kindergarten's going great. She spent like all of her time over Christmas. She must have been working on her material that the teacher sent home. We're doing great. We're going to be really good going back after Christmas. Well, Callie, the astute 8-year-old, kind of motioned to me the other day and she said, Mom, Marin is smart, but that kid just got a watch for Christmas. And Marin sits directly behind me in the car, and Marin is sitting there going, 3 plus 6 is 9. 9, like she has a calculator in her watch that I didn't know about. And so the kid has been calculating her math behind me the whole time at 5 years old. And I was like, I forget I have a calculator on my Apple Watch Ultra. I forget the calculator's there. But this 5-year-old, again, giving us a run for our money. But it reminded me how it is important to remember the tools at our hands, right? Remember that we have the technology, we have the innovation. The whole realm that I work in, innovation is to do things a little bit easier, to do things a little bit quicker, a little bit more efficiently. So as we talk about the foundational side of math and calculations and all of that, think about the tools that you already have at the tips of your hands that can help you be a little more like Marin. How many of you had this teacher? I did. Said, you got to learn this. You need to show your work. You will never grow up and have a calculator with you all the time. Yeah, LOL. Look at them. All right, so why do we talk about math for pest control? Why is it important? Why do we teach our kids how to use the calculators on their watches? First and foremost, documentation. Right, we as pest control professionals have a certain standard to deliver as far as customer service and regulatory compliance that makes us do the math behind what we're putting down. So documentation being the leading indicator for why math is important. There's also a really important calculation to make as far as profit and loss. If you're not doing the math correctly and you're putting too much chemical down, that's loss, right? You're putting more than is required to do the job. In general, your product cost of service should be less than 5% of the total cost out of your pocket. If you're drastically over that, then that's time to look at efficiency and where we can get that product cost down. But again, use as much product as required by the job and use math to get that number of how much product is required by the job. Otherwise, you're risking loss without any reward. The environment. Putting too much chemical into the environment is not a good thing, simply put. We are all stewards of the environment, so whether we're talking about fipronil or pyrethroids or even water consumption, it's important to remember the environment and calculating the amount of material that is supposed to go into the go down to do the job that we intend it to do. Again, a leading indicator for why math is important in pest control. Property damage. How many of you have seen someone or the result of someone mixing too heavy and causing property damage? Maybe it's in the form of staining, interior staining on baseboards, scaling of windows, phototoxicity when plants are burned. Too much product is not a good thing. Less is not, or more is not better in this situation, right? So avoiding property damage and maintaining the relationship with our customer is another huge reason why math is important. Incidental exposure. So what goes down is intended to kill or control the listed pests that are on that label. If it goes over that, then we start seeing secondary effects for non-target organisms, correct? So whenever we don't do math correctly and there's an accidental over-application, we worry about the overexposure to non-target pests. So, and of course, you want to assert social dominance. So being better at math is a good way to do that. All right, let's talk a little bit about math fundamentals. How many of you can throw a baseball? Not well, just get it out there. So whenever I played about 19 years of basketball, I still consider myself a pro. Kareem Abdul-Jabbar was my first childhood hero, all because I wore goggles and he did too, so we were the same. I was blind, he was blind, we were good. Anyway, when I learned to shoot a basketball, I remember being taught curl, press, and follow through. And you had to repeat that over and over again, like curl your hand, press it into the basket, follow through, watch the basketball. Maybe if you learn to throw a baseball, you learn to step first, throw the ball, and watch it go. So whenever we talk about fundamentals of any process, I think of it in that way. It's really clunky at first. You're thinking about all the steps, but eventually you take a step out, and you don't have to think about it as much. Math is very similar in that whenever we're learning math, we want to understand the problem first. And depending on what kind of learner you are, maybe it's a verbal learner, auditory learner, visual learner, understanding the problem looks a little bit different. So the fundamentals include understanding the problem of knowns and unknowns about your problem. So what do you know about what you're trying to solve for, and what is that unknown? My mom was a physics teacher, and I set up every physics problem just like this. And I continue to use this analogy in all of my even non-math related questions. What do I know and what do I not know to help me solve the problem? You want to identify relevant operations. And so whenever we go through today, you'll see relevant operations. What is another word for that? Formulas. Where we can look at formulas for solving problems in a quick and easy way. It's systematical, it creates the same avenue for an answer every time, and it's like a cheat sheet. You want to be able to break down a problem. So if you are standing outside of a home and there's a lot of unknowns, being able to take each part and say, this is what I know about the situation. I know how many linear feet are here. I know what my label says. I know how many ounces are in a gallon. That is breaking down the problem so that you're able to digest what you need to know to provide the best service, right? So taking a moment to break down the problem becomes the fundamentals of this process, but also checking the solution. How many of you have done a math problem on your phone even, and you're like, that doesn't look right? That happens anytime. Anytime you do math, you hit a number wrong, you carry a 1 wrong, and it's important to look at the answer and make sure that it makes sense. So if you are standing outside of a home and it says, hey, you need to put 15 gallons down of this emulsifiable concentrate, you're like, I've never done that before. I don't think that math is right. That's an important part of the math fundamentals, is check for the solution. So examples of knowns and unknowns. Percent active ingredient. That's often a known because you have a label in your hand, right? Volume of concentrate. It can be a known in that a lot of manufacturers, depending on which formulation you're looking at, will put that number somewhere in the label. Sometimes it's on the front page right under the active ingredient. Sometimes it's buried deep. You also generally know your treatment area. You rarely walk into a situation you're like, I know I want to use this product, but I don't know where I want to use it. Your known is always going to be where you're putting that thing. And then general conversions. I want you to don't forget that you know how many ounces are in a gallon. You know how many feet are in a yard. Those are all knowns, whether they're relevant to your math problem right now or not. So don't get hung up on forgetting the basics. Unknowns can also be the treatment area as it relates to calculating that treatment area. So we'll go through that a little bit, just a refresher course. Calculating volume of concentrate. Again, it's not always on the label, but it's fairly easy to get to. And then also, treatment area again, apparently put it in twice. So where do I find my numbers? Every label is going to look a little bit different based on that formulation. And it's just requirements by the EPA is, do we look at pounds of active ingredient per acre? Do we look at how much is going into the environment this many times a year? Pyrethroids will have that stipulation. It has to do with whether it's a granule formulation or a liquid formulation. It's going to look a little bit different. I pulled 2 arbitrary labels, don't come at me. This is a Onslaught Fast Cap. It has multiple active ingredients, which is interesting for calculating percent active ingredient. But MGK, who makes Onslaught Fast Cap, does a really good job of putting, and I'm not patting myself on the back, I didn't write this label. They do a good job of putting percent concentration of active ingredients in a table. And you'll see that a lot of manufacturers have started to do that. They take out the guesswork of calculating this so that it makes your job a little bit easier. But they also add in dilution rates of how much water. So when you always, whenever you're doing an application, most people assume, well, I need 2 ounces or I need 1 fluid ounce per gallon. That's an easy way to do the math, but you don't have to use a gallon. If the equipment that you're using really needs a smaller droplet size, or maybe you're using a surfactant, you can cut down to half a gallon of water. So don't get hung up on the 1 gallon of water in all these calculations, in that the gallon of water is kind of arbitrary as long as you get the active ingredient out there. Another example, Alpine WSG, chose this one because it's a granule, but also water soluble. Their label looks a little bit different. And then again, this is just an example of, you got to go dig for it, but once you get used to the products that are in your APL, the math becomes a lot faster. So math for concentrations can be broken into, again, this is going to be a little foundational. I want you to remember that going back to the basics can help us be more efficient. So whenever we look at math for concentrations, we're generally looking at 2 forms of numbers. We're looking at proportions and fractions, which are just ratios, how much of something else is in this formulation, meaning 2 parts out of 5 make up the total volume. If you're a language learner, excuse me, if you're a language learner, you're going to read that as A is to B, as C is to D. So what are the relationships look like as it relates to the percent concentration? If you're a symbols learner, that's me, I like visuals. You're going to look at it as 1/2, a half, is equal to 4 out of 8, which is also a half. We're also going to look at percentages. This is a unit of a proportion. I'm going to take this water a second. So whenever you are a language learner, that is, what is 25% out of 80? That would be your math problem you're solving for. Whereas, again, back to the symbols, 0.25 times 80 equals what? So anytime we're doing calculations based on area, percent concentration, any of the above, we're looking at these 2 things. Forgive me. All right. Proportions and fractions. Who knows who N is? Has anybody ever found N? We're going to find N. And again, this is a reminder how to calculate quick math on the go. So this is going to be a step-by-step process. We're learning to throw the baseball, shoot the basketball, so that you can do this in your head. Forgive me. Whenever you are in the field. So calculating proportions and fractions, how do you solve for N? Exactly, you cross over. So you turn that equal sign into a multiplication sign. So cross multiply 2 times N to solve for N, but you multiply 8 times 1. That's going to be a super easy answer. Do those math problems so that you get 2N. 2N equals 8. What do you do now? Divide by 2. So to get the 2 away from the N, you bring it back around and you divide 8 by 2. Gives you an answer of 4. be solid if you could mute me whenever I cough. Okay. Everybody got sick over Christmas. I'm not the only one. Okay, so what does this look like in a word problem? Thank you. The label indicates that 2 pounds of granular insecticide are to be applied for 1,000 square feet. How much do you need to apply in an area that's 5,000 square feet? That's a word problem. You're reading the label and you're like, man, I don't know how many square feet I have. So we'll address that later. You're going to go figure out how many square feet you have. But in this word problem, you know that you have 5,000 square feet. How do you get to how many granular insecticides? Now, the antiquated way, if you're not, like, you're like, I've avoided math. We've all had those things where we just like are mentally refused to learn. If you avoided math, no more. We're learning math today. So if you avoided math, you would go, all right, let me put a 2 pounds down every 1,000 square feet. That makes you incredibly inefficient. So let's express this as a proportion so that, again, we're solving for n. How many pounds? I know I have 5,000 square feet. How many pounds am I going to put in that area? So cross multiply, we get 1,000 times n, and we get 2,000, or 2 times 5,000. Make those numbers happen. You get 10,000 on the right side. What do? You carry that 1,000 number over to divide by 1,000. 10,000 divided by 1 is, we're using 10 pounds. Does that make sense? So that's taking a word problem, a very simple word problem for purposes of our demonstration, and turning it into a quick cross multiplication that as you learn to shoot the basketball and as you learn to throw the baseball, you will start to be able to recognize your known factors in that problem statement that you're pulling off a label and solve for it quickly. Who hated learning how to multiply fractions when you were in school? God, I hated it. It was like, I had the biggest pencil and it was not taught right. And I just remember like, I'm not gonna learn this. I don't know what I have to do, but I'm not learning this. And that was multiplying fractions. But as I grew up and as I taught it to myself, you're like, it's not so bad. So here's the problem statement. If you have 67 ounces of water that were collected from a nozzle in 1 minute, calculate the flow rate in gallons per minute. First, determine the target measurement units in your answer. In this case, we're looking for gallons per minute. To me, this is like the question of if the train is rolling at 67 miles per hour and you got a sandwich ready in Dallas, like how long till you get to lunch? You're like, wait, there's a lot of information happening in this statement. How do I pull out what is important and what is just like fun that the teacher was having when she wrote the question? So as you can imagine, you're like, all right, what nozzle am I using? How much time do I have? How much is 67 ounces as it relates to a gallon? All of these things. So remember, go back to your known and unknowns. What are you actually solving for to get to the answer? So let's express this as a proportion. On the left side, you know that you have 1 minute, and you know that you got 67 ounces out of it. I reminded you earlier that a lot of the knowns may not be stated in these problem statements because you know there's 128 ounces in a gallon. And so you can align, for multiplication of fractions, you can align units across the fraction. They don't have to always be on the same side. So align them across the same side and they are able to cancel each other out. And so we are solving for what that gallon is. So to solve, in this case, determine how many gallons per minute. You get almost about half a gallon. All right, let's move on to percentages. Mix 3 gallons of a 2% pesticide solution in water. Easy enough. So let's convert that percent to a decimal. And everybody, for those of you who don't recognize, you can take a percentage number and just move the decimal 2 places to the left and get the decimal spot. It looks like this. You can also punch it into your phone. But that's what a decimal point percentage looks like. And then to determine the number of ounces in a pesticide needed per gallon, what do? You multiply that in ounces. There's 128 ounces per gallon. That's 2.6 ounces of insecticide. Multiply that by the number of gallons you're trying to get in this word problem. We're shooting for 3. That's 7.8 ounces of concentrate. Another problem that you may run into at some point is how much active ingredient per space. A lot of times this will be more relevant in T&O applications where you have large areas of outdoor applications. So I want to give you a couple examples of this arbitrary product I made up. New Stuff X, a 75 WP, apply it at a rate of 1 pound per acre. An example of this in real life would be how Delta Guard G is worded on the label for applying for external T&O pests. So to calculate the percent active ingredient, you need to identify the relevant operations. So for a dry material calculations, this is your formula that you'll be using. So amount of active ingredient divided by percent active ingredient in decimal form equals the amount of product. So in this instance, we're breaking down that product to say, we know for 1 pound of active ingredient per acre, there is a 75% concentration of that active ingredient in this made up product, New Stuff X. So that gives us 1.33 pounds of New Stuff X per acre. And to solve for the application area, meaning now how much is needed to treat 16 acres, because what we know from the label is 1 acre, but now I have 16. How do we get to that without putting 16 doses down? All you do is take that number of pounds per acre, multiply it by the amount of space, in this instance 16 acres, and you get 21.3 pounds. In that formula, it's really important to remember that what you are calculating for acres needs to be similar to what was prescribed in the label as far as pounds per acre. If it wasn't, convert that number to something that is samey. Looking at a liquid of New Stuff X, what did I call this stuff? New Stuff X 4EC is my arbitrary product, and I want to know how much active ingredient per 1 pound when applied to an acre. This would be very similar to Bifin IT, which is labeled, you can see the mosquito control, outdoor applications of an EC what do they have it labeled at? 0.07 to 0.22 pounds of bifenthrin per acre. You're like, what does that mean to me? This is your formula that you use for liquid active ingredients. So again, the carriers are different, so your percent active ingredient is going to change. So pounds of AI over pounds of AI per gallon equals your gallon product. Breaking down that problem by pulling information from the label, 1 pound of active ingredient per label or per acre is what we got from our arbitrary label. And we know that we get our number 4 from the concentration of what this, again, made up product is, and you get 0.25 gallons per acre of liquid active ingredient. If we have 16 acres, once again, we do that multiplication and say that we're putting 4 pounds of this made up product onto 16 acres. So switching gears a little bit, because that was all about calculating percent concentrations and understanding how much active ingredient was going into our finished solutions, it's also important to look at math for area, because if you watched James Miller yesterday in the exhibit hall, we were doing Pi Chi Omega. Some people call it bags, cornhole, there's a lot of names, but anyway, we were playing cornhole and he was like, it's 27 feet between the holes, and you're like, okay. And he was like, 27 feet is like 9 of these, and if you've seen James Miller, he's like, you know, I was like, that's like 40 feet. So understanding math for your application areas is just as important as understanding what you're putting into a tank or a spreader. So let's look at 4 different application areas: spot treatment, perimeter treatment, area, and volume. So what is a spot treatment? 2 square feet? Okay, so per the EPA, it's not to exceed 2 square feet. Good job. So what that also means is that 2 square feet doesn't have to necessarily be square, right? It can look a lot of different ways, but 2 square feet in that that's the amount of area that is covered for a spot treatment. So these are a couple different ways that you can look at 2 square feet. Perimeter calculations can be described in linear feet, aka LF, but essentially if you are looking at a rectangle, 2 times the side of A plus 2 times the side of B. Very easy. If you have a perfect square, not all of us do all the time, you just take 4 times the length of one side. Easy math, but also remembering that it's easy math can help level a really hard problem. So don't forget, don't be afraid to do that. Now we just looked at perimeter calculations. How do you look at perimeter treatments? So when it comes to insecticides, we know that gallons per square foot, cubic foot of a product is different than just understanding the size of the area you're treating. So for a perimeter treatment, you do start by calculating that perimeter, right? So 2 times, in this instance, we have a perfect 10-foot by 30-foot house. We wanna understand how much material we're going to put down outside of that home. So 2 times 10 plus 2 times 30. Do your multiplications inside of your parentheses first, then add those numbers together, and you get 80 feet, 80 linear feet. And we want to calculate for volume of insecticide when a 1 foot footer is prescribed. So in this instance, 4 gallons per 10 linear feet is what the label calls for. So we know we have 80 linear feet. We can pretend that this is a termiticide backfill post-construction treatment. 80 linear feet with 4 gallons per 10 linear feet prescribed. You know that we need 12 gallons roughly of product for that. I'm looking at the word gallons and I'm like, is that spelled right? Gallons. You ever see a word like that and you're like, that just doesn't look right. Anyway, calculate for the volume of a 4-foot footer. You get obviously 4 times the total volume. All right, area calculations. This is very similar, right? You're looking at the entire area, much like the house is not built. You're doing a pre-treatment. So you want to treat entire area under a slab. How do you calculate that? That is expressed in units of square feet, aka FT big little 2, or square foot, and that is easily done with side A times side B. Now, I'm oversimplifying this, right? How many houses look like this? Not a lot, not a lot of them. But the ability to break out footprint into little rectangles and calculate percent area makes it a little bit easier. I wish we all had that. Volume treatments, length times width times height, length times width times height. Expressed in cubic feet because you're filling a space. But you can do this by calculating the length of side A times side B times side C to get a cubic foot volume. All right, let's do this. Let's do a little bit of math to kind of use the tools, use the formulas that we've gone through so far. So like I've watched you do math. I want y'all to help me do math. All right, let's calculate the perimeter. Can anyone help me do this? We got a 60-foot linear foot on the long side, 40 on the short side. 200, good job. Did you use your watch? I know. Well, and that's the thing, is you've done that math so much that it becomes second nature, right? And that's what we're trying to get to, is these foundational skills of cross multiplication or solving for n, whomever n is, gets us to the answer a lot quicker. So we use that formula, 2 times the short side, 2 times the long side. All right, let's make it a little bit harder. So the application is 3 gallons per 1,000 square feet of surface over the softscape, including a treatment of 2 foot up and 2 feet from the 2 foot up and 2 foot out from the foundation. How much product would be needed? Same foundational footprint, buildings built, we're just doing linear foot applications, 2 foot up, 2 foot out. I'll let you think about it for a second. I'm going to walk you through the formula. So we start with that perimeter. We solved for 200 already. But we want to also calculate the 2 foot up and 2 foot out. So we take that number and we get 4 foot because you have 4 foot of linear space going vertical and horizontal. And you take that and multiply it by your 200, you get 800 square feet. But I'm still stuck with the unknown of how much product is needed. We know from our label, our known information, that 3 gallons is needed per 1,000 square feet. So that becomes a known fraction of 1,000 square feet over 3 gallons. Because we're not cross multiplying, we keep our square feet on the top, and we solve for X to get, we solve for X, let me take a drink of water. We solve for X to get the gallons of product that are needed, which is our unknown. Good job. We need some engineer math up here. So you get 2.4 gallons. Thank you for your help. So what I'll do, guys, is I know that Purdue can share presentations. And again, I struggle with word problems where someone's like, hey, what's this math, without being able to write it out. So I want you to be able to look at some of these equations and work them out in your own world with your own products and your own APL. So I'll share this presentation and you're welcome to do that. All right, so now that we know foundational math, and if you all remember basic math class, it was, I need to see your math and I need you to write it out. And they still teach kids that. And it's because you want to understand how you got to the answer. But it's also 2024. And you all are here and we just learned math. So I think it is okay that now that you understand the foundation of why we need to understand percent concentration and what factors go into that number, that we use the tools that we have with us to become more efficient. So I brought up I would assume that out of all the technology out there, most of you use the calculator on your phone. How many do use the calculator on your watch? 1 or 2, not a lot. I forget it's there, honestly. So that's another thing. You know, we look at hands-free technology all the time, especially in pest management, because your hands are dirty. They're in bait stations. They're handling dead things. You're like, what do I not want to touch? I don't want to touch my phone. And so how do we get the math happening without touching things is an issue. So use your phone, of course, and you don't have to do this where your hands are dirty. But also, I use the ChatGPT icon because it's kind of like saying I TiVo'd that when you're really just using a DVR. Using artificial intelligence to solve problems is something you should all be doing. Adapt. Artificial intelligence is moving faster than any of us can describe, but I don't see, I did use ChatGPT and I said, hey, can you help me solve this problem? And I put a couple just arbitrary problems in that kind of what we talked about today, but had a little bit more detail, a little bit less detail, and it was easy it spit everything out as if I was teaching it to you or you were teaching it to me. So use artificial intelligence when possible. Also, on your phone, and I found pretty good success with it, you have a measure tool if you have an Apple phone to where you can measure distance without actually stepping it off. And it can measure distance of solitary objects. So if you need to know how long that stem wall is, literally just scanning the camera over gives you a really good idea, and it's fairly accurate. I wouldn't say to the inch, but to the foot. I can get 90 feet away and be dead on with 90 feet. Also Siri, speaking of hands-free. Hey Siri, what is 800 divided by 3? Oh, I thought she was going to talk to me. She does basic math, okay? She does basic math. I have tested it a couple different ways, and on the problems we talked about today where it was like, hey, can you give me percent concentration? Siri doesn't do that. Siri's like, here's a Google link. And you're like, thanks. I need you to do the math. I think that one day virtual assistants will get to that stage where they're able to solve complex problems with institutional knowledge, but right now she's like, I'm good with division, but I'm not doing percent concentration based on your active ingredient. So use the tools at hand though. You know, you don't have to whip out your calculator on your phone if you can ask Siri to do simple math. All right, it wouldn't be a talk by me if we didn't talk a little bit about innovation. Google Glass is really cool. Augmented reality is emerging, and how we apply that to pest management is really important. So I want you to think about flying cars and how, if you watch the Jetsons when you're growing up like me, I kind of thought we'd already have some. We haven't. But I do think that, actually we do have flying cars. Let me forget it. We don't broadly use flying cars, but they do exist. But Google Glass is like that to me. How do we take something that is commonplace, like wearing glasses on your face, and take the technology with augmented reality and adopt it to what makes us more efficient and safer in pest management? And so the ability to use this tool on your face to measure distance or do calculations, because you can also check your email and the weather just by what is happening within the space that you're seeing. I think that's a potential for innovation here. I also see that while we do a lot of calculations on how much active ingredient is going into the environment and what we should be doing to be stewards, that naturally that we will move towards a library of products that are by default better for the environment. So there's less risk to contamination or less risk to non-target because of the way we're able to develop formulations. So math will almost become secondary or not necessary because we've engineered a formula or we've engineered an active ingredient that prevents that non-target risk or over-application worry. There's a lot of key drivers that we look at. These are 4 that I use in my side of the world that say, you know, this is key drivers for growth and innovation in pest management, but if you think about them as it relates to just doing math in pest management, the presence of pests. We all say that, I mean, business is always, you know, business is good because pests are always around us and they're always around our customers, but understanding where those pests occur will change our need for math. Right now, we talked a lot today about just calculating linear feet and outdoor applications. But as insects move inside, or as insects begin to infest different commodities, the math changes. So how do our tools for doing that math change as well? You also have sustainability and regulatory pressure just changing and really driving a lot of the decisions we're making in pest management. So how does that change how we're calculating what we're putting into the environment and what products we're using? Food and feed safety, we got to feed the world. So that's being a huge driver of pest management. And then also just everybody's aware of the consumer demand for IoT and remote monitoring. Everybody wants to know, everybody wants to be a part of the conversation now, and that's great because it keeps our customers engaged. But when it comes to just doing math and understanding how much product is going out around their home or into their business, they're going to have to come in and understand these simple foundational processes as well. So our ability to automate that will be really important. I always end every conversation or any ideation session, Pat and Alex can attest to this a little bit, but like, why does this matter? Like, why does this matter that we spent 45 minutes so far on math to your license, to your business, to your Tuesday morning? Resistance, as you've heard from a lot of speakers in the past and probably some speakers today, resistance is a problem that we have to manage for. And so if you are over-applying insecticide or under-applying insecticide, you introduce the risk of resistance in different populations because you're either under-inoculating a population, not killing them all, and they're just building up their immune system, right? Or you're leaving too much in the environment to create a fringe of resistance for an untreated area. So understanding where you're putting chemical and how much is going down per the label, what a manufacturer has decided will kill a population in that area is really important. Phototoxicity, we want to keep as many plants as possible. You want to keep as many customers as possible. So not burning plants, not killing plants due to over-application is really important. We want to protect our tools. There are a lot of agencies and groups out there that see what we do as not a great thing. And they make it their mission to identify ways to take our tools away from us. And so an example of that would be taking water samples from areas in California, where they say, you know, out of every 10 water samples pulled from this region in California, we're getting X number of fipronil positive hits. Well, that opens up our industry to losing that tool. So as stewards for your tools and stewards for this industry, it's important that you apply things at a label rate that will reduce runoff, reduce drift, and you know, kind of allow us to keep those tools in our tool bag because we are applying them correctly. Your bottom line is really important too. If you're putting too much out there and we just really didn't need that much product, then let's check the math. Let's go back and make sure that you're only using what you need to, because everybody knows materials are expensive. You are all, I've said it before and I'll keep saying it, you are all stewards of the environment. It's not up to one person to scream sustainability and talk about green, whatever that means, to change the world. It's up to all of us to make sure that we're stewards of our environment and stewards of our customers, and that's why this matters. But also, beyond sustainability, is safety being the driving factor for all of this. We want to keep our technicians safe, we want to keep our customers and their pets safe, and if that wasn't enough, it's the law. So, let's see. One more meme, and I'll take some questions, if there are any. There's your QR code. Go for it. Oh, absolutely. So AI being artificial intelligence, I think it's a tool, much like fipronil is a tool for termite control, but not the end-all be-all it's not the silver bullet for termite control. Artificial intelligence is just one of the tools in your tool bag for becoming more efficient and more correct. And so, I mean, you're 100% right. All right, I'm always happy to talk about innovation or math every once in a while. So thank y'all for having me.